Hello everyone. This video will show how to graph the function y equals arcsine of x. Now we remember that this notation that we have right here is read as inverse sine of x or arcsine of x. So I'm going to go ahead and write that down here. Now please remember that this notation that we have right here is not 1 over sine x, because this 1 over sine x is cosecant x. Now let's go ahead and graph this y equals inverse sine of x. So we are given this graph right here, which is y equals sine x. Since we're looking for the graph of the inverse of sine x, two graphs are inverse of each other if they are symmetric with respect to the line of symmetry y equals x. So we're supposed to be drawing the inverse graph for this y equals sine x. So what we're going to do here first is to trace. I'm going to go ahead and trace this graph using a pencil. Okay, the next thing that I would do is I will reflect this across y equals x line of symmetry. So I'm going to go ahead and fold this. And what I would do is trace the graph at the back of the paper. Once we open this, we should be able to come up with a graph that is symmetric to the original graph that we just did. So in this case right here, I'm going to go ahead and trace this graph here. Now notice that this graph right here is not a function because it does not pass the vertical line test. So what are we going to do here is that we will restrict this graph such that it becomes a function. So we can go ahead and say that this graph can become a function, or this green graph here can become a function if it's gonna be from here all the way down here. So if you notice, if we label this part right here, this is the restricted portion and this is a function. So what we do is to figure out what are the coordinates for this two dots here. So looking at the original sine graph here, this is actually symmetric to this dot is symmetric with this dot right here. And this dot is symmetric to this dot also right here. So what we do is figure out what is the coordinate for this. So this is located at pi over 2 and at 1. And then we go ahead and determine the coordinate of this other dot here. Now we remember that if they're inverse of each other, we just have to switch the position of the x and y. So this dot here will have a coordinate of 1 and pi over 2. And we're going to do the same thing for this other dot right here. So this is negative pi over 2, and then this is negative 1. And we're going to switch it. So that means the coordinate for this dot here is negative 1 and negative pi over 2. So mathematicians have agreed that this is the graph of y equals arcsine of x, or y equals inverse sine of x. So we go ahead and determine the range for this graph. So looking at this, the range for this graph is from negative pi over 2 up to positive pi over 2, while the domain for this graph is from negative 1 all the way up to positive 1. So again, the equation for this graph right here is, we can therefore say that since our range is from negative pi over 2 to pi over 2, these are the possible values for y, and negative 1 to 1 are the possible values of x. Now looking at the 4 quadrants here, so we go ahead and draw the quadrants here. Based from this, we can go ahead and say that our values for inverse sine of x or arcsine of x are defined within this range right here. So in which quadrant are they located? Now we remember that if we go counterclockwise direction, that's a positive. So this spot right here is positive pi over 2. And if we go down clockwise direction, that's a negative. And this spot right here is negative pi over 2. We can therefore go ahead and say that inverse sine of x or arcsine of x are defined only in the first quadrant and in the fourth quadrant. So inverse sine of x and arcsine of x are not defined in the second and third quadrant. Now let's look at the graph of y equals inverse sine of x or y equals arcsine of x on Desmos. If you notice, the graph that we've created on a paper pencil version is the same as the graph that we have on Desmos.